All right, I lied. I got really excited by the fact that I could be done with new material as of this afternoon, so I thought, what the hell, let's go for it. So what we're going to do now is we're going to put directing groups to practical use. And once again, just because I'm a little obsessed, here's the directing groups chart. All right, let me shrink that a little so you can see it better. You've really got to know these. Now, because this is an online-only format, there's not a big deal with you having these in front of you as you do your problems. But I just want to reiterate how really important it is to know these and to know what you're doing with them. So let's go ahead and do a first. I want you, this is 2 steps now. I want you to show me how to make this. I don't care about mechanisms right now. I really don't. What I want you to do is show me how to make this. Now, I'm going to walk you through this one in a step-by-step process. So, the first thing I want to tell you is this. Look at the relative positioning of the groups. So for these two, they are, hopefully you can see that, para. Then you need to think about what can make you, what you can add, the order of addition here. So the 2 groups are a chloride, which is done with chlorine and aluminum trichloride, and a sulfonic acid, which is done with SO3/fuming sulfuric. Okay? Now you've got those 2 facts down. So now the second thing you do is you think, what do I add first? Now, this is going to be where I think almost every one of you are going to make this mistake at one point or another. All right? So you're going to look at sulfonation. You're going to look at the sulfonation piece. And you're going to say, okay, SO3, fuming sulfuric acid. If I go back a page, I see SO3H is a meta director. That means it's going to go on meta. And that's not true. What you have to do is look at the groups that are on there and figure out the order you need to do this in order to get you the positioning you need. So, for example, in our situation here, what is chloro? What is chloride? What is chlorine? That's the name of the fucking element. What chlorine? Is that an ortho, para, or is that a meta director? Look at that. So, you know that chlorine is an ortho-para director. The SO3H, what kind of a director is that? La 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 la. It's a meta director. Oh, sorry. And now, the positioning of those 2, the chlorine and the sulfonic acid, they are para with respect to one another, right? So, in order to make this, what you would do is you would start with benzene. And since we're not doing mechanisms, you can very absolutely easily use the circle form of benzene. The first thing you'd want to do is put the ortho-para director on there, which would be chlorine and aluminum tri, which puts you here. And then you'd sulfonate using SO3. Technically, you should write fuming sulfuric acid, but that'll do. And there's your product. Now, common mistakes. SO3 is a meta-director. Why wouldn't it go on meta to the chlorine? Answer. The direction only counts for what is already on the ring. What's gotten in there and planted the flag first. Okay? So, yes, SO3H is a meta-director, but the chlorine, which was in there first, is the ortho-para-director, and that is the one you listen to. So now, let's talk about this. Now, I want you to walk through the logic steps on your own that we did on the previous page. And if you need to, go back, rewind the video, and take a look at that direction table again. Go ahead, I'll be right here. All right, everybody, let's take a look at this. So the two groups you have on here are a bromine, which is added with bromine and iron tribromide, and a nitro group, which is added with nitric acid and, why was I about to write out sulfuric? Dear God. H2SO4. What is the connectivity of the two things already on the ring? Hopefully you can see. They are meta to each other. So now the question is, what is the order of addition? What do you need to put on there first? And to answer that, let's look at the kind of directing groups each one of these substituents is. Bromine is an ortho-para-director, and nitro is a meta. So knowing all of that, your order of operations to make this meta-bromo-nitrobenzene would be starting with benzene, we nitrate it, to get nitrobenzene, which you know is a meta-director, and then you would brominate it using bromine and iron tribromide to make this. Quick reminder, and it probably applies to this page a little bit more. Yes, Cl is an ortho and a para-director, but remember, the ortho position is usually sterically blocked by whatever is hanging out there, so we don't have to worry about it. So generally, you just go straight to para. All right, let's do another one, and we're going to up the difficulty here a little bit. All right, pause the video. I want you all to think about how to make these two molecules. All right, how to make these two molecules. Go ahead, pause, think this through. I'll be right back. All right, let's keep going on this one. There are a couple tricks that you need to be aware of for this one. This is why, honestly, knowing these tricks are going to help you. Okay, so what is the overall orientation between those two groups? It's para to one another. Okay. What are your two groups? Well, one is an iodine. which is added using I2. I2 and nitric acid. The second one is a 3-carbon propyl group. Now there's a problem here, because normally iodination is easy, I2 and HNO3. Here's the problem. You cannot do this reaction. This will actually give you, this reaction, 1-chloropropane, aluminum trichloride, and benzene, will actually give you this for your product, remember, because there is some rearrangement type chemistry that happens in there. So you cannot directly propanate that ring. What you can do, though, if you'll remember, we have a workaround for this. What we can do is we can acylate that ring using an acid chloride. Wow, that is just ugly. Let's start that whole thing over again. Using an acid chloride and aluminum trichloride to give you this. Now, it's not quite what you want yet, but the reality of the situation is, do you know how to go from here to here? And the answer is yes, you do. It is zinc, mercury, and HCl. Now that you know how to put both of those groups on, the positioning really doesn't matter that much, because both the alkyl group and the iodo group are orthopara-directors. So you could do this in one of two ways. I'll show one of them, well, because it's the easiest. I2 and HNO3 to form iodobenzene, which you then react with the acid chloride, aluminum trichloride to give you this, which you then reduce that off with zinc and mercury and HCl. All right? Now, I'm running out of time, so we're going to do this one in the next video. All right? So there are a couple ways that we can accomplish this, but I'm going to try to go easy ones first. So see you in the next video, ladies and gents.